Welcome everyone. So I'll begin the discussion about the RunModel module of UQpy. The RunModel module is the essential tool which UQpy uses to interact with Python software, models in Python, or models in other third-party software. So the function of RunModel is to pass inputs to the computational model, execute the model, collect the output from the computational model back into RunModel. And RunModel is the module which other UQpy modules also use to link to computational models. So we have already seen, as Professor Shields has discussed, the modular structure of UQpy, and there are several modules which need a computational model to be executed. And RunModel is the interface which these UQpy modules use to execute computational models. So over the training session today and tomorrow, each of these modules will be explained in detail further. As you see here, in the context of a typical UQpy application workflow, you would first need to generate inputs to models and evaluate these models, and then post-process the output from these models. And several UQpy modules allow you to do these activities. For example, sample methods module, which will be discussed later today, and the transformations module and the stochastic processes module, all of these allow you to generate samples of random variables or stochastic processes or random vectors or random fields. And all of these samples can be, which are generated by UQpy modules, can be directly passed in as the input to RunModel. And RunModel will execute the computational model and collect the outputs. Now, other UQpy modules, such as the surrogates module or the reliability or inference module, can utilize these outputs and do some more processing over it, as according to the application which the users have in mind. So who needs RunModel? So any user who wants to use UQpy to propagate uncertainty through models in their applications needs to know how RunModel is set up and how it functions. Also, any users who want to use the reliability module of UQpy need to be familiar with how RunModel works, because RunModel is used in the reliability modules. The same case is true for people who want to run inference applications using UQpy. They also need to be familiar with RunModel. And there are several capabilities which use gradient information. For example, the gradient enhanced refined stratified sampling is a sampling method which is in the sample methods module. So anybody who needs to use this capability needs to also be familiar with RunModel. And there are also several other applications in future which will need users to know how to execute a model. So people who are interested in any of these applications need to be familiar with how UQpy runs models. The command used to import RunModel into Python is as shown on the screen right now. So from UQpy, import RunModel will import the RunModel module. The module consists of one single class also called RunModel. This class can be directly imported using the following command. So this is usually the first step which users have to do in order to access the functionality of RunModel. And RunModel has 5 workflows which are defined by 3 input attributes of RunModel. So setting the values of these 3 different input attributes will trigger different workflows. At the first level, the attribute called input template defines the way UQpy interacts with the model. So there are essentially 2 workflows, either with the use of an input template file or without an input template file. So the the appropriate workflow is triggered by the parameter called input template. And in the second level, after selecting a particular workflow, either a serial or parallel execution of models is conducted. This is done by specifying the parameter called end tasks, which defines how many tasks are run at a time. And finally, in the parallel execution case of the third-party software workflow, there is an additional parameter called cluster, which specifies additional options for parallel execution on a cluster, if running on a cluster. So by specifying these three input attributes when RunModel is called, we can select different workflows of RunModel. Each of these will be explained in detail during this presentation. So in the first case, if the model is in Python, UQpy can directly interface with the model without the need for an input file. So by setting the input template equal to none when RunModel is called within a Python script, the Python model workflow is triggered. So on this screen, we see what are the different attributes for running a Python model workflow. So the essential required attributes for running a Python model are the samples and passing a model script to RunModel. Now, the way these samples are generated will be covered in more detail later today as well during the sample methods training session. So the following command shows how the RunModel is called within a Python script for users of UQpy. RunModel accepts all these input attributes, and this table shows what each of these input attributes represents. Samples have to be passed into RunModel. So generating the samples which are used in UQpy is not part of the RunModel execution. So that is a prior step. And then, so once samples have been generated, they are passed as an input to RunModel. And RunModel also needs a model script to be specified. And within the model script, the model object is a function or a class which executes the model. And RunModel needs to know if there is only one function or class within the model script, then there is no need to specify the model object name as an input. RunModel will find the correct model object and execute it. Otherwise, if there are more than one model objects within the model script, it is necessary to specify the model object name as an input to RunModel. And specifying the value of end tasks will trigger either the serial or the parallel workflow. And the model directory is a path to the directory within which the model is run, and any outputs generated are saved in that directory. Verbose is an option which just prints additional status messages to the terminal when the model is executed. So this can be used to debug any issues which arise while executing the code. This functionality is still under development, and currently a few messages are printed to the terminal when the verbose option is set equal to true. The output generated by RunModel is an attribute called QoI list. So this is a list which contains the output quantities of interest, and the length of the list is equal to the number of samples which is passed into during the simulation. Now the samples which are passed into RunModel are usually either passed in as an n-dimensional array or as a list. If an n-dimensional array is passed as the samples, each row of the n-dimensional array contains one set of samples required for one execution of the model. And here, the first dimension of the n-dimensional array is considered to be the number of rows. If a list is passed as the samples input to RunModel, each item of the list contains one set of samples required for one execution of the model. So these are all the required as well as additional attributes while running a Python model using RunModel. When a Python model is run with RunModel, that model script, which is defined as the input attribute, is imported into Python. And this model script contains a model object, which is also passed in as an input. RunModel will execute this model object, which is defined in the model file. After the model object is executed, any model outputs are collected in the QoI list, which is an output attribute of the RunModel class. So the model script must have an object which can be either a function or a class which contains the computational model. Samples are passed to this model object, and if the model object is a class, it should execute the model and store the quantity of interest, which is the output, as an attribute of the class. So it should save it as class.qi. This is a requirement of using RunModel. If the model object is instead a function, it should return the quantity of interest after taking one input, one sample as input. So this slide shows an example of how a model script is defined. So the model object could be either a class or a function. So this object should take as an input one sample and execute the model using the input and collect the output. Now, if it is a class, it should save the output as self.qi. If it is a function, it should take one sample as the input and return the output. So this is the name of the model object is as shown here, as indicated here. So this is passed as an input to RunModel when the Python model workflow is defined. At the second level, when the input template is set equal to none, and by selecting n tasks equal to 1, the serial execution of the Python model workflow is triggered. If n task is set to a value greater than 1, then the parallel execution is triggered. Now, to run the models in parallel, we use the Python module called concurrent to execute n tasks number of model executions in parallel. This slide shows the structure during serial execution of the Python model. So in this, n samples number of times the model is evaluated with one sample passed as input, and RunModel will save the output quantity of interest as the ith value of the output attribute QoI list. So it should be kept in mind that the Python model should be set up to accept one sample and return the quantity of interest. During parallel execution, n task is set to a value greater than 1, and n task number of samples are passed into the model script, and the outputs are collected and saved in the appropriate index of the QoI list. So RunModel manages the bookkeeping, and ith sample is, and the ith QoI quantity are managed, the bookkeeping is managed by RunModel. So we will now show an example Python notebook of using RunModel. So I ran the Python notebook, which I just ran the example notebook, which runs a Python model. So let me restart and run it again so that we cannot follow. So we need to import the RunModel class first into this Python script. And the first step is to generate samples, which will be passed as input to the RunModel. Now this is done using the MCS class, which will be discussed in a later session today. Now this xmcs.samples is passed as an input to RunModel. So we just generated 10,000 samples here, and we will evaluate the Python model named sum RVs, which is stored in this Python file called Python model class.py. So let me just show the structure of Python model class. As I explained before, so when we define the model object to be a class, the output of the model evaluation should be saved as self.qi. So RunModel just executed that model with 10,000 input samples and collected the quantities of interest. By setting n task equal to 1, which is the default value, the serial execution was performed. By setting n task to a value greater than 1, triggers the parallel execution of the RunModel class. So in the second case, now we can also describe the model object as a function. So in this, the model script called Python model function is used, and which contains the model object called some RVs. So if we see the structure of the Python model function, here instead of a class, a function is defined, which takes the input and returns the output. So if the model object is defined as a function, then this is how the call to RunModel is given. And RunModel takes care of executing the model at these input sample points and collecting the output. And by default, by setting n task equal to 1, the serial execution is triggered. By setting n task equal to 2, the parallel execution is triggered within RunModel. Now we'll return to the slides and continue to the next part of the presentation. So input file usage is the second workflow based on by setting the value of the input template file. Now, why do we need this? If the model is not in Python, then the UQpy interacts with that model through an input file. As well as, now, even if the model is in Python, if additional inputs are necessary to build or execute the model, in addition to the samples, random samples at which we want to query the model. So even in this case, it is recommended, even if the model is in Python, to use the input file based workflow of RunModel. This workflow is triggered by setting input template to the name of the template input file. RunModel interacts with a text-based input file identified by the name input template. So this is a text-based input file. It does not have to be a .txt, so it can have any extension. Samples are passed in, and the model script is executed using the input template. And then an output script is defined, which post-processes the output from the model and returns the quantity of interest to UQpy. So in this slide, it shows the approach of UQpy to interface with models through input files. Essentially, we require a template input file with placeholders where the samples of the probabilistic inputs should be present. So this template input file contains all the information necessary to construct the model or to execute the model. So in addition to the non-deterministic inputs, which are passed as samples, there could be other deterministic inputs which are required to build the model, or there could be other inputs which have to be specified to execute the model. So in all these cases, all of that information is usually presented through a template input file, One particular example is, for example, if we want to run simulations, finite element simulations, then in addition to the sample values of the non-deterministic inputs, we also need to pass in information which is used to build the finite element model as well as to execute the finite element models. So usually all of this information is present in the form of an input file which is used to run the to execute the model. And also, even if we want to use the same strategy to interface with any other third-party software model which is not in Python. So here the strategy is, first we use the template input file and create n samples number of input files, where each of these input files corresponds to one sample using the template input file. So there are placeholders within the template input file which are replaced by values of the probabilistic input variables. And then RunModel executes the model script with subprocess module of Python. So it essentially goes to the system, calls the system and executes the third-party model, because this is not a Python function. So this is the strategy which is used. Now, model script contains all the commands which are necessary to execute the model. Model script is a Python file. It's a .py file. So it contains all the commands which are necessary to execute the model. And the way it should be set up is it will take one input, which is the sample index. So it is not the sample value. It is just the sample index, which is indexing from 1 to n samples. And then the Python module called fire is used in the model script to create an command line interface to the model object. So detailed examples of this will be given next. And then the post-processing of the model outputs is performed by another Python script, which is called the output script. This returns the quantity of interest back to RunModel. And this is the strategy which is used to run models which are not in Python. So essentially, using a template input file, we can interact with any model which is not in Python as also. And examples will be shown next. So this is summarizing UQpy's approach to interface with models and third-party software. So we use a template input file and the model script along with the samples, the probabilistic samples, to build n input files, where n is the total number of samples. Now each of these input files are used to evaluate the model, and the model produces an output, which is post-processed using the output script.py, which returns the quantity of interest back to RunModel. So in this table, all the input attributes required for running the third-party model are shown. So the samples is a required input, as well as the model script which has to be run, and an input template. So input template is a required input which triggers the third-party software model workflow. And these will be explained in detail here. So this slide shows how RunModel has to be called for a third-party software execution. As was the case for the Python model execution, samples can be either an n-dimensional array or a list. Model script is a string which contains the name of the Python script that includes the computational model. The input template is the name of the template input file which is required to generate input for any of the models. Variable names is a list of strings which contains the names of the template of the variables which is located inside the input template. Now by default, UQpy creates variable names of x0 to xn if a list of strings containing the variable names is not passed as an input. Output script is the name of the Python script that is used to post-process the model. It is again an optional input to run model. Output object name is similar to the object name in the model object name in the Python workflow. So it is the name of either a function or a class which is used to collect the output values. Number of tasks is an integer which defines either the serial execution or the parallel execution. And there are additional options which will be explained later. Now the variable names which is passed as an input is a list of strings where each string represents the name of the variable which is present in the template input file. The template input file, which is a text file, a text-based file that serves as the template for third-party models. So each of the text strings in the variable names. So UQpy search for each of the variables within the template. Once it locates that particular variable, it is replaced by the numerical value of the sample for that variable, which is passed in as an input to run model through the samples. The user should ensure that the order in which they specify the variable names matches the order in which the samples are passed to run model. Run model uses and the ith value of the ith row of samples passed in, if it is an n-dimensional array, or the ith entry inside the list of samples, and it builds a template input file by it builds an input file corresponding to the ith sample which is input to run model. And always run model saves the generated input files within a subdirectory called input files of the current directory. Now this example shows how a template input file has to be written and how run model processes the template input file to generate different input files. For example, this is a template input file which is passed in as an input. The name of this template input file is MATLAB model.m. So that is passed in as an input to the call to run model. And then the variable names is specified to be variable 1. So run model first scans the template input file and tries to locate variable 1 within angle brackets. Once it finds any instance of this specified variable name, it then uses the samples and replaces the entire angle, the placeholder, which is the angle brackets enclosing the variable name, by the numerical value of the sample. And it appends the sample index to the name of the template input file and creates an input file which will be used to execute the model. So for example, here there are 3 samples which are passed in as input, and it is a univariate quantity which is passed in as the sample. So run model created 3 input files because there are 3 samples, and within each input file, the corresponding value of the sample has replaced the placeholder. So the first input file now contains the first entry of the sample. The second contains the second sample, and the third input file contains the third sample, and so on. So this example shows how an input file has to be structured and how run model uses such a template input file to build inputs which are used as to build files which are used as inputs to execute the model. Now, if we look at this, we'll look at the structure of the model script next. RunModel calls the model object through the command line when executing the third-party model. So in order to allow RunModel to do so, we use the Python module called Fire. So this is installed when we install UQpy as part of the requirement. This is a part of the requirements of UQpy. So the Python module called Fire is automatically installed. In this, the Fire module creates a command line interface, and it makes the model object accessible from the command line. So within the model script, we have to include an example for using Fire is is shown here. So within the model script, if we include these lines, if name equals main, fire.fire model object, where model object is the name of the object which contains the commands to execute the model. So if this line is placed within a model script, this makes this model object accessible from the command line. And RunModel can now execute this model by using the following command using the subprocess module of Python. So on Windows system, RunModel automatically calls Python instead of Python 3. On other POSIX systems, the appropriate call to Python is Python 3, and it uses the name of the model script and passes only the sample index, which is the input to the model object. So this sample index is utilized by the model object to locate the appropriate input file called input_n.inp. So this input file is an input file which has been generated by RunModel using the template input. So the sample index is used to locate this input file, and then one execution of the model is performed by commands located inside the model object. This slide shows how a model script can be written. So the model object can again either be a class or a function. Now, the inputs are just a sample index instead of actual value of samples. So we're just passing in the sample index. So this is how the model should be structured. So it should accept only the index as an input. Once it takes the index as an input, it locates the input file, which is within a subdirectory called input files always. And then it executes the model corresponding to that index to get one output. Now, in this case, the output is not something which is saved within the model class, but it is something which has to be accessible to the model script. So through the output script. So there is an additional output script which will take the model outputs and return the QI back to RunModel. So there is no need to save the quantity of interest within the class or to return it within the function. So if the way to use Fire is to give the name of the model object. So if a model class is used, it will just have the name of the class here. Or if the model object is a function, it will just have the appropriate function name here. So this is the structure which has to be used to create model scripts. And this example shows how such, so for the same set of samples as in the example before where we saw how to generate input files with the template input. So for the same example, this is how the model script looks like. Now, this is the model object, it's called model. It takes the sample index as an input, and the model script contains a call to Fire, which makes it accessible through the command line. So within the model object, so it contains all the commands necessary to execute the model. So first, it locates the input file, which is always in the directory called input files within the current directory. So it finds the appropriate input file, and then it, so this command is just executing the model, and then the third command is doing something to the output. So all of these commands upon running this, so this is one execution of the third-party model. Then we'll talk about the output script now. So this is an optional user-defined Python script. Now this is used to post-process the model output and get the quantity of interest from the third-party model files. And now this returns the quantity of interest back to the RunModel. So within the output script, an output object is defined, which is passed as an input. The output, the name of that output object is passed as an input to RunModel. UQpy will import this output script, and it executes the output object, which again should accept only the sample index as an input. And again, it can be either a class or a function. If it is a function, it should return the quantity of interest. If it is a class, it should save the quantity of interest within the class as self.qi. So this shows the process of generating input files, running the model, post-processing the output, and extracting the quantity of interest back into RunModel. And this is the essential structure which is used to execute any third-party software models using a template input file. Now within the directory containing the where the call to the model execution originated, so we might also need to have additional files which are necessary for the model to run. For example, if we are running a finite element software, we might have some libraries which define any user-defined material models or something. So any additional information which is necessary to execute the model will be present in that directory. So one of the inputs is model directory. So if to run model. So if this input is passed, so RunModel first creates a model directory within the directory from where it was called, and it copies all the contents of that directory into the model directory. So if we then look inside the model directory, so these are all the contents which are copied, and so when RunModel is executed, it creates a new folder for each run of the model. So for example, if an Abacus model is executed, so it generates several files during execution. So we don't want the working directory to be cluttered with all the files. So there is a separate separate folder created for each run of the model, which contains any. So if we see the structure inside any of these directories, so any files which are created during the execution are present here. Now there is a subdirectory called input files within this directory because it was created when RunModel built the input file using the template input. And also all of the necessary information to run the model is copied into this directory by RunModel. So whenever this new run directory is created, the necessary information is copied into it. Input files is a directory which is created when the input file is created by RunModel using the template input. And then the model script is run. Any other files created during the execution will be stored, will be saved within this directory. So this is how, if a model directory is specified, this is the directory structure. Now, if a model directory is not specified, then the difference is just, so everything is within the start directory. So it doesn't go inside the, so within the start directory, we have all the input, all the files. And then for each execution of the model, a new folder is created. So into which all of the files necessary for execution are copied first, and then a new folder for input files is created, and any other files created during the execution will also be present within that directory. So far, we saw the strategy for running any third-party software models using an input file. Now at the next level, so we would want to use parallel execution of these models. These could be models which could be computationally intensive. So we want to run these models in parallel. So RunModel allows parallel execution of these models using GNU parallel. So by setting ntask to a value to an integer greater than 1 during the input, will trigger the parallel execution. If it is set equal to 1, it will perform a serial execution of the third-party model. In the serial execution, for each execution of the model, the ith sample value is taken as an input. The ith sample value is used along with the template input file to create the ith input file to the model. Now this ith input file is used by the model script to run the third-party model, and then it generates some model output. So this output script post-processes the model output to obtain the quantity of interest, and that quantity of interest is again stored in the ith value, in the appropriate value by RunModel. And this process is repeated n samples number of times. So as many samples there are, so that this loop, it loops over the number of samples. Now within the parallel execution, so that was the serial execution on the previous slide. So if ntask is set greater than 1, so again, the execution could be on a local machine or it could be on a high performance computer, HPC cluster. So as I said before, RunModel uses GNU parallel to execute jobs with input files in parallel. Now, when execution is on a local machine, so RunModel builds the necessary GNU parallel commands. If execution is on a cluster, so we support execution using slurm commands. So RunModel automatically builds in these slurm commands into the model command, which is used to execute the model. So all of this is already implemented. So the users will just need to pass in the samples to RunModel. In this case, first RunModel generates all the input files using all the samples. Then it runs ntask number of models in parallel using GNU parallel. After all the models are evaluated, all the model evaluations are done, then the output script does the post-processing of the output, and it just takes in one model output at a time and extracts the quantity of interest. So this is repeated in n samples number of times, and then the output is stored into QI list. So even though execution is in parallel, so the appropriate quantity of interest is stored at the right location. So there's bookkeeping taken care of by RunModel. Now GNU parallel has an option called resume. If all the model evaluations did not finish for some reason, so GNU parallel allows resumption of the model, of the execution of the model. So we don't need to perform the executions of all these models again. So this option is also supported in RunModel. So this is an input to the RunModel class. So the way to use it is the same samples have to be passed in. And again, the same command has to be executed, but by setting resume equal to true. Now, if the execution is on a cluster, so that is triggered by setting the input attribute cluster to true and ntask greater than 1. So then the slurm commands called nodes and course per task are the two commands which is currently supported by RunModel. where node is just a server with some amount of memory and some processing units, where each processing unit is called a core. So all the cores within one node share memory, as well as each of these cores has its own memory allocation. So these two commands are currently supported in RunModel. So if you can execute, you can specify how many nodes to use and how many cores to use per task. For example, if there's a finite element model and each execution of the model has to occur in parallel, so you can specify how many cores to use to parallelize each execution of the model by setting cores per task to that integer value. So to recap, RunModel has several inputs which perform, which define so of these inputs, first, we define all the model inputs by passing in the samples as an input to RunModel. And we define the model within the model script and the model object name. So these are required. So samples is a required input, model script is a required input. And we also have to specify an input template if we are using a third-party software. And variable names is also an optional input now. So these 4 inputs define the model, and model execution details are specified by n tasks and n cores if running on a cluster, and the number of nodes. And then other inputs are passed to RunModel, which specify how to post-process the output from the model output. So which is the output script and the output object name. And then we also define what directory structure has to be used by specifying the input model directory. And then there are other options, which is verbose. So these are all the inputs to RunModel, and the outputs to RunModel is the quantity of interest. Now these outputs from RunModel can be used by other UQpy modules, or you can do any further post-processing depending on your application by taking the quantities of interest, which is output from RunModel. So I'll now show 2 example files which show how a MATLAB model is executed or an Abacus model is executed, and how uncertainty is propagated through these models. So I'll first show the MATLAB model. Let me run this. So here there is first a model script which is called MATLAB model.py. I can show the. So during the third-party execution, only the index should be used as an input within the model script, and the model script should contain this line, which makes the model object called MATLAB accessible through the command line. And this model object contains all the commands necessary to execute the model. And this is done by RunModel using the subprocess Python model module. Now we saw that the execution has completed. So I took so it just evaluated this model and the model object called MATLAB, which we just saw, using this template input file called dummy model. So within this template input file, now there are 3 variables which are probabilistic, which are passed in as samples. So if we see the example, we first generated 3 samples. We only generated 3 samples, but so it's a trivariate normal distribution. So we pass in the variable names as an input. Now the variable names are defined here as a list of strings called variable 1, var1, var2, and var3. So if we see the template input file, so this is where these variables are defined within placeholders. So this input file is essentially just summing up these values, the 3 values. And then there is an output script called process MATLAB output. So again, it is structured as a function here, which takes in only the index as an input, and it returns the quantity of interest. So we saw that these are now, so always the output is saved as the QoI list attribute of the RunModel object, and it contains the quantity of interest from these 3 executions of the MATLAB model. So this is how RunModel has interfaced with the model, which is not in Python. And it's the same script again by run in parallel by setting nTask equal to 4. So it returns the same outputs, but it takes lesser time to execute. So GNU parallel has to be installed for this to run. So there is another example file, which is a abacus model.
Just an additional note on this, these files, these scripts, notebooks will not run on the Binder site because Binder does not have MATLAB or Abacus installed. So these require MATLAB and Abacus to be in the path of the local machine.
Yes. So now this example file, let me just start running it. Yeah. So it has started running the abacus model. So it is waiting to reconnect to the kernel. Yeah, let me just rectify the problem here, just a second. So the kernel has had to be restarted. It was stopped. So that is why there is an error. Yeah. So we are right now in executing an abacus model in serial. So this shows, so the abacus model is being executed in the background. So while it is running, let me just show the details of the Abacus model, how the Abacus model is set up. So the Abacus model is specified within this model script. Now, as usual, so whenever there is a model script, it has to contain this line called to fire, which makes this model object accessible via the command line. So if we see this model object, it is a function called run single element. It takes one input, which is an index. So once it takes the index, it locates the input file to the Abacus model, which is a .inp file in this case. And input files are always located in this subdirectory. And it builds the two commands. The first command runs the Abacus model with this input file. And the second command processes the output database, which is generated by running the Abacus model. So this is the structure of the model script. Let me show the template input file. So within the template input file, if I go back to the notebook, so here we define one variable name, which is E, the string E for Young's modulus. Now within the template input file, there are all these additional information which is used to build the model. And in the template input file, there is this placeholder called E. So RunModel locates this variable and replaces it by the appropriate value of the sample to generate an input file. So this model has now finished execution. So it is just a single element model, and there are just 3 samples. So it successfully executed this Abacus model, post-processed the output from the model, and extracted a quantity of interest, which in this case is the stretch strain curve of that output from that single element model, subjected to boundary conditions, which are all specified in the input file. So this shows how third-party models can be executed in using RunModel in UQpy, and the setup which is necessary to run third-party models. So that is the end of the session on RunModel.